Ciao, Algebra 2. Today we're going to be talking about section 2.4. This is a new topic, imaginary numbers. And it's November 10th. I hope you did well on your quiz. So what is an imaginary number? Okay. So the imaginary number is the square root of a negative number. So we use I, the lowercase I, to represent the root of a negative number. So in the past, if you used to get a final answer of the square root of -1, you would say no real solution, and now you're going to say that is actually equal to I because it is defined as so. Then we can work with imaginary numbers. Alright, so some stuff you need to remember. Remember the following, and I'm gonna doodle because I'm tired and it's fun. Alright. So fun. Okay, anyways. Remember, so we don't actually write it as the square root of -1. Simplest form is I. So I to the first power is equal to I, and that is the simplest form. We don't actually write I to the first power because it's not considered simplified, so we would leave it as I. I squared is equal to the square root of -1 squared, which we know that squaring a square root cancels it out, so this is actually equal to -1. Not -I, -1. Okay, so I cubed is equal to, well, we could think about it as I squared times I, right? So I squared times I, well, that's just -1 times I. So I cubed is equivalent to -I. And I to the fourth is equal to, well, we could break that down to I squared times I squared, and that's equal to -1 times -1, and -1 times -1 is +1. So you really want to remember these four, I squared, I cubed, and I to the fourth. Now you could always solve for it. I mean, we just solved for it. It took me, I don't know how many seconds, but it did not take that long. So when in doubt, you could solve. But you should be working with this enough to know all of them. So why is this important? Well, because if we want to simplify, understanding that I to the fourth is equal to 1 is really important. So let's do some examples where we have to simplify. Simplify, no, funny. Do I get a smirk maybe? Okay, anyways. So if I have I to the 1, let's just do 21st. I to the 21st power. Okay, so you could simplify this by saying like I times I times I times I times I like 21 times. Or we could remember it as, hey, this we could think about it in terms of I to the fourth. So this is the same as I to the fourth times I to the fourth, right? Because 4, that's 8 times I to the fourth times I to the fourth times I to the fourth times I. And I to the fourth times I to the fourth, this is just 1 times 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 I. So this is actually equivalent to I. Now a little trick. It's not really a trick, it is math, but it would be considered scrap work. So off on the side, one thing you could do, by understanding the idea that I to the fourth is equal to 1, we can say, okay, well, how many times does 4 go into 21? And I'll explain why. So 4 goes into 21, well, 4 times 5 is 20. And when we subtract, we get 1. So we have a remainder of 1. So that means that we're going to have I to the fourth 5 times, and then 1 I value. So let me show you another example without writing all this out and just doing this little step. So I to the 99th power, right? Because we don't even want to write I to the 4 out that many times. That's just ridiculous. So we could say, okay, well, how many times will we have I to the 4th? How many times does 4 go into 99? Well, 4 goes into 9 2 times, right? 2 times 4 is 8. 9 minus 8 is 1. Bring down our 9. How many times does 4 go into 19? Well, 4 times. 4 times 4 is 16. And 19 minus 16 is 3. So we have a remainder of 3. So what that means is we would have I to the 4th, right, this, written 24 times, and then we would end up with an I cubed. So I to the 99th power is actually the same as I cubed, and I cubed is the same as negative 1. So I do want to see if it's I squared or I to the third. I want to see you write that before you simplify it. So let's do, I don't know, 2 more examples, I guess. Let's do 1 more example. Let's do I to the 40th power. So I to the 40th, I could do my little long division trick and go, okay, how many times does 4 go into 40? Well, that goes in 10 times, right? And here we get a remainder of 0. And I to the 0, well, we didn't talk about that, but hopefully you remember from Algebra 1, I to the 0 is the same as any number to the 0 power, and that's just 1, right? And it'd be I to the 4th 10 times, which is 1 times 1 times 1 times 1 times 1 times 1, 10 times. So it's just 1. All right, another time where we need to use this is not just simplifying, but simplifying radicals. So you learned about simplifying radicals a while back. I think you do a little bit of it in geometry, I don't remember. It's been a while since I've taught it. So use square roots to solve each equation. Be sure to write your answers in simplest form. Okay, so x squared equals 16. So this is just to refresh your brain on the process. So one thing a lot of teachers don't teach, but I already have, see if you remember. This is very, 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 very beginning. is when we take the square root of both sides to solve for x, this becomes plus or minus x, because the square root of 16 is just 4. But that's not simplest form because we want x by itself. So the plus or minus is actually over here. And that's our final answer. You don't have to show this line, but I just want to make sure you understand it. So if I just gave you an expression of, hey, what's the square root of 16? It's just 4. Okay, let's do a problem with imaginary numbers. X squared equals negative 9. So you used to not simplify this anymore. You would do this and then go, no real solution. But now you know about imaginary numbers. So you're going to go, well, x squared, oops, we just took the square root, that was silly. X is equal to plus or minus, and then inside our radical we have a negative 1 times 9 is how we can think about it. And the square root of 9 is 3. And the square root of negative 1 is I. So this is actually plus or minus 3i. Okay. It's bothering me. Let's do another. Let's do x squared equals negative 27. So again, take the square root of both sides because there's nothing else to do. And we'll give you harder problems later, but for now. So x equals plus or minus the square root of negative 1 times, and then you want to simplify this to see, hey, are there any perfect squares? So what times what gives you 27? Well, 3 times 9 gives us 27. So the square root of negative 1 is I, the square root of 3 is just the square root of 3, and the square root of 9 is 3, so that means we can take out a 3i. And we are left with the square root of 3. Alright, let's do one more. Although I'm running out of time because I don't pay for Screencast-O-Matic. X squared equals 216. So when you're simplifying radicals, because I do expect you to remember how to do it, first of all, I want to see work. I want to see this because, I don't know, we're remote. You could cheat easily. So x equals plus or minus, and then inside the radical, simplify it. Now, this is going to be different for everyone. Maybe you think, actually, sorry, I wanted that to be negative. So this is negative 1. Maybe you're like, I can't think of anything. Well, it's even, guys. So just divide it by 2. And you'll get 108. A trick is like with your calculator. So I don't want you to do this in your calculator. But in your calculator, you could divide 108 by some of your perfect squares, like 4 or 9 or, I don't know, 16. So if you divide it by 9, it's actually 9 times 12. Okay, and you can always check in your calculator, negative 1 times 2 times 9 times 12, are you getting 216? Okay, so I mean, if you wanted to at this point, you could start taking out some perfect squares. So square root of minus 3, and we have an I, so currently we have plus or minus 3i on the outside. But this isn't completely simplified. 12 is the same thing as 4 times 3, right? And that's another perfect square, right? The square root of 4 is 2. So this becomes plus or minus 3i times 2. And then we still have the 2 times 3 inside our radical. So altogether, this simplifies to be plus or minus 6i times the square root of 6. So you could have divided by 36 in the beginning, but that's okay. So make sure you have some work.